So last class, what we worked on was proving triangles are congruent. And you guys had some opportunities to learn about the different theorems that prove triangles are congruent. You did some simple problems that let you demonstrate just putting in the givens, writing the theorem that you're, or the conclusion you're trying to prove, and choosing whether it was ASA or SAS, etc. Then your homework was to do more challenging ones. And these were more challenging because there were a couple components. One, would you be quiet, please? One, sometimes pieces were missing, right? The types of pieces that were missing were either segments or angles. And in the events you're missing segments or sides, we found that reflexive was used a lot. Sometimes we'll find that the definition of a midpoint would help us with that. Sometimes you were missing angles, and we found that vertical angles were used a lot, although there are other choices for that as well. Sometimes we'll see the parallel line theorems coming back, or the definition of angle bisectors. And we had two occasions to use Cpctc. The challenges with Cpctc are that you don't necessarily know exactly what triangles you're trying to prove congruent. In this case, number 12, for example, you're asked to prove that DA and CB are congruent, but how are you supposed to know which triangles to prove? So that's what we're going to work on today. I've got a picture here. How many triangles do you see in this picture?
5, 4, 5, 6, 2, 3, 5, 6,
372. Can we agree that this is one triangle? Can we agree that this is one triangle? Can we agree that this is a triangle and this is a triangle? And that's all we see. There's 4. This thing in the middle is a quadrilateral, doesn't count as a triangle. So the question becomes, if we were trying to, for instance, use Cpctc to prove that CB and CD are congruent, which triangles would we want to prove are congruent?
CAD and CED.
Okay, good. CAD, the yellow one, and CEB, the pink one. Because if we can prove those are congruent, the yellow one has CD as a side, and the pink one has CB as a side. So that would work. And how you name it is what we talked about with the triangle congruent statement. You can name it CDA, as I did here, but then the corresponding name has to be CBE so that the corresponding parts match. And that ensures for us that CD then matches with CB. So what about for this one? If we were trying to get DF to be the same as BF? Good. So BFA and DFE would work. Any questions on this concept? So today what you're going to be doing is there's 2 parts. The first part is asking you to do exactly that. Identify the triangles that would be necessary to prove this fact is true. So in this case, BFC, we're trying to prove that this angle, AID, is the same as this angle. What would be a pair of triangles that would let those two angles be proven congruent by Cpctc? Yeah, Kenyon?
BFC and AID.
Good. BFC. So what I'm going to do is over here, I'm going to pull out BFC label it, and then I'm going to pull out the other one and label it. I'm separating them so they're no longer overlapping, which is what was causing the biggest difficulty. And I'll mark the angles that I'm looking for, ensuring that the full angles are present in the triangles. And then I'll make the triangle congruent statement. What should I call this triangle? I could call it BFC, I call it CFB, I call it CBA. I'm going to call it CBF just for giggles. The first one gets to be free. I can name it whatever I want. But once I do that, what's going to be the name of the second one? CBF. So I'd have to go DAI. Well, and actually, I guess we don't really know in this case because it could be ADI. We don't know that B and A align or C and D align, but we can guess. Okay, what about for the second one? Take a look at that. See if you can figure out which triangles have to match. Let's try someone else. Yeah, Mark May.
As far as I know, you would just be splitting it, BAF and CAF.
Okay, I like that. So you're saying that BAF would be one of the triangles, and that gives us segment AB. And you're saying we can just use this other part over here. Did anybody see two different triangles? In other words, he's saying, I see this as one of my triangles, and this as the other one. Yeah, what'd you see?
CDI.
CAI?
CDI.
CDI. Well, CDI would not be a valid choice because it's got to have AC in it. And CDI doesn't have AC in it. It's probably congruent, or it looks like it would be, but it wouldn't be taking us down a path that helps us at this point. But could we have chosen this one? Doesn't that also have AC in it? Yeah. So whichever pair you pick, you draw them out, and then you create the triangle congruent statement for them. I'm going to say in this case that triangle BAF is congruent to what triangle? It looks to me like, and I know I'm guessing here, but A looks like a right angle and B looks acute. A looks like a right angle and C looks acute. I would guess it's going from C to A to E. Again, we don't have the right information to make sure about that, but that's what this activity is designed to do, is make you think about how the triangles fit together. Any questions about what this activity is asking you to do? Yeah. Say again? Say it again. I'm not hearing you.
F not E, right?
F not E. B, A, F, C, A. Thank you. C, A, F. I see what you're saying. Yep. I made a mistake here. I couldn't read over my notation here. Okay. Once you finish these, the backside is going to ask you to actually write some proofs. Real proofs. What does that mean? Well, it's going to start with two columns, isn't it? What's the title header on the left column? Good. Statements. And the right? Good. Reasons. How should we begin?
Given.
Take my first given. AC bisects angle DAB. My reason for that is given. Now, before I move on to my second given, I'd love to be able to take the information from this given and put it up here. I'd love to be able to draw it in my picture. But really what I need to have is a congruence thing. I need to have something that says these are congruent, not something that leads me to believe that they're congruent. So I need to change this statement into something else. I need to extend it. What does it mean that AC bisects DAB? Yep, someone said it, that DAC is congruent to BAC. And why do I get to say that? What's my justification? Yeah, I had previously said there was an angle bisector, and this is what it means for that. In other words, it's the definition of an angle bisector. And that takes care of my first given. And now I've got a notation I can put in the picture based on that. Now I'll put up a second given. AC bisects angle DCB. Given. And what can I tease out of that piece of information? DCA and BCA? ACD and AB. Yeah, you can do it that way. ACD and ACB, that would be fine as well. And what would be my reason for that? Yep, let's be clear and say angle bisector, because a segment bisector would have a different impact and a different meaning. And that then gives me the second angle. And as I've talked about for proofs in general, if we don't know where to go next, one way is to go to the end. Remember, like in the back of the Denny's menus? If I know that the final step is going to be angle D, screw it to angle B, I can write that and just leave some space for myself. What's going to be the reason for that?
Well, if we do like this symmetric property quality, AC equals C, AC.
Okay, so you're filling in the middle part here, but give me just the one step for this last piece. Yeah.
It's the ASM.
ASA proves triangles are congruent.
Oh, Cpctc.
There you go, Cpctc. My point is that if we can think about proving these triangles are congruent, then we could say that any corresponding parts of the triangles are congruent. So if we're going to say this is Cpctc, I must, just before that, have stated what Canyon was working towards, that these two triangles are congruent. So what should I call this top triangle? Let's get someone else. DAC, I like it. But now that you've chosen DAC, we have a very specific title we have to call this bottom one. Good, BAC. I have to use the corresponding parts in sequence. D matches to B, these A's match, these C's match. Now, in order to prove these two triangles are congruent, I've got to use one of my rules, SAS, SSS, ASA, SAS, one of those things. But do I have three facts here to do that with? So far, I've got 1, 2. What's my third thing I need? Yes, sir, Colin. I did.
AC equals AC.
Good. AC is to AC, which gives us a side. And the reason for that is reflexive. Good. And with that in place, I can now make those marks in my picture. And now it's easier for me to see these triangles are similar by what? ASA. Good. This is now a complete logical proof. This fact leads to this. This fact leads to this. This fact comes out of reflexive. These three facts make the triangle congruent. Once the triangles are congruent, I can say that corresponding parts of congruent triangles are congruent to come up with a conclusion. Therefore, QED. Any questions? All right, you have the rest of the period to complete this sheet and submit it in Canvas. I encourage you to work together.